Hello and welcome to Lesson 7 on Solving Quadratics by Factoring. Today we are going to make connections between the real roots of a quadratic equation and the x-intercepts of its graph. So let's look at our first example today where we have x squared minus 2x minus 24 equals 0. So first we're going to use factoring to factor this. So please take a moment to try this on your own. And you should get x minus 6 and x plus 4. So now, I used this in our previous lesson, but here's now the official definition for it. But we are using the zero product property. So what this property tells us is that if we have two numbers where their product is equal to 0, so A and B, we are multiplying them to get 0, then either A is 0 or B is 0, because anything times 0 will give us 0. And the only way a multiplication can give us 0 is if you're multiplying by 0. So, or we can have a third option where A and B are both 0, and 0 times 0 will still give us 0. So, to solve the factored form of the equation above, we're first going to let x minus 6, so its first factor, to equal 0. And this gives us x equals 6. Next, we'll let the second factor equal to 0, so x plus 4 is equal to 0, and this will give us x minus 4. And so now, if you substitute the value of -4 or 6 into our original equation, x squared minus 2x minus 24, you'll see that you should get 0 for both of those. So I'll give you a moment to try that, and then I'll show you my calculations. And here's now the check using left side equals right side. And please don't forget to include these two last statements because that's essentially what we are doing with our check, which is to verify that these two are the solutions to our equation when it equals 0. And here we see that it does. In both cases, we are getting our final answer to be 0. And so these two are roots or solutions to this equation, and they're roots to the original function. So now, what are the roots of this function? F of x equals 9x squared minus 25. So here, we're going to set the function to equal 0 again, because that's essentially how to find the x-intercept. So the x-intercept is when y is equal to 0, or in other words, when y, which is equal to f of x, or our output, is equal to 0. So we set 9x squared minus 25 equal to 0. So now we're going to factor here. And I'll let you try this on your own first, and then I'll show you how I did it. So I hope you recognize this as our difference of squares because we have a squared is equal to 9, so a is equal to 3, and we have b squared is equal to 25, so b is equal to 5. So then we can write this as the difference of its squares to get 3x minus 5 and 3x plus 5. So now, using the zero product property, we want this to equal 0. So either this first bracket is equal to 0 or the second bracket is equal to 0. So let's look at each of those scenarios. So if 3x minus 5 is equal to 0, then 3x is equal to 5 and x equals 5 over 3. And in this case, we get 3x plus 5 is equal to 0, so 3x is equal to -5, and x is equal to -5 over 3. And so we'll just rewrite that now here. So this one was 5 over 3 and -5 over 3. So now I want you to look at the equation we had here. 9x squared minus 25 is equal to 0. And I want you to think, is there another way that we could have solved this problem? So if you look at my solution here, I used basic algebra to solve for x here because this is a matter of an equation with one variable. And I see that if I move 25 to the other side by adding 25 to both sides, then I can divide by 9 and I have x squared equal to a value. And then I can take the square root. And this part is really key. Maybe let me highlight this so don't forget this part. But when you do the square root, you need that positive and or the plus or minus because your value could be positive or negative. And alternatively, if you square this value, in both cases, you simply get 25 over 9. So whether it's positive or negative doesn't make difference when you square it, but when you find the square root, you do have to acknowledge that there's two possible solutions. And here we're just using our property of square roots to distribute it over the fraction to get square root of 25 and square root of 9, which gives us 5 over 3. And that's the same answer we had here of positive 5 over 3 and negative 5 over 3. So right over here. So either way would have worked here. If you were more comfortable factoring first, that's totally okay. And if you were able to see the solution and tried it this way, totally okay as well. You get the same answer. So now we're looking at another problem with point of intersection, similar to the ones we saw last lesson. And in this example, we're asked, what is the point of intersection of the function f of x equals 4x squared plus 20x and g of x is equal to negative 25? So again, we want to know for what value of x is f of x equal to g of x, or in other words, 4x squared plus 20x is equal to negative 25. So we want to find an equation where it is equal to 0. So I'm just going to add 25 to both sides. And now I have a quadratic equation that is equal to 0. And I can think of it now that I have this new equation and I'm finding the solutions to this equation. So now let's factor using decomposition. And here we are looking for two numbers where their product is equal to 100 and their sum is equal to 20. So you can try trial and error or the method we have learned, and you should get that our two values for decomposition are 10x and 10x. So if you factor, we get 2x plus 5 and 2x plus 5, or 2x plus 5 squared. If you had recognized it here, and I tried to show you both ways because I want to show you that whether you recognize them or not, if you try decomposition, you will get the same answer regardless. But for difference of squares and perfect squares, if you do recognize them, it makes your life a lot easier and you can find the factored form faster. But again, if starting out, they're not as familiar to you, try just the decomposition method and that should work as well. So here we had 4x as a perfect square and 25 as a perfect square, and their square root, so a in this case would be square root of 4 or 2, and c in this case would be square root of 25, which is 5. And so b is 2 times 2 times 5, or 20. And so we would have had our perfect square as 2x plus 5 squared, which is what we got here. So now, if we are to use the zero product property here, we are saying that this square bracket is equal to 0. Essentially, we are saying 2x plus 5 squared is equal to 0. If you take the square root, this is the same as 2x plus 5 is equal to 0. And so x is negative 5 over 2. Now let's look at the graph of these two. And that's exactly what we see. So negative 5 over 2 is the same as negative 2.5. And we see that when our f of x function for x squared plus 20x is graphed with that red parabola, as well as our straight horizontal line g of x is equal to negative 25, they do end up intersecting at that point, negative 2.5. And the value that they share is that negative 25. Keep in mind, this is a straight line. The only value it can be is negative 25. So now, um, we've seen this before as well, but it's nice to put definitions and just solidify some of our concepts. So if you have a quadratic equation, ax squared plus bx plus c, if you can write this in factored form, where the a will be factored out so that it doesn't actually affect your brackets. So you still end up with x minus s and x minus r, so that x does not have its coefficient, then your solutions here will still be s and r. But if you have a coefficient for either of the x's, definitely work on just setting that bracket as equal to 0 and solving for the x value there, which is what we did here, and we got some fractions. And generally, fractions is okay. Leave your answers in fraction form, or if you're using a calculator at times, just convert it to decimal. That's okay too. So now let's look at our last example for today, where we have a word problem. And we're told that the path of a dolphin that is jumping out of the ocean is modeled by h of d is equal to negative 0.2 d squared plus 2d, where h of d is the height of the dolphin above the water surface, and d is the horizontal distance from the point where the dolphin breaks the water's surface. And both of these measurements are in feet. So with word problems, first, please make sure you understand what the variables are representing. So a diagram always helps. So I imagine the sea level here. And if my dolphin leaps out, pretend that's a dolphin, um, and it kind of follows this pathway, then this over here is h of d, the height above the water, and this distance here is d, the horizontal distance that the dolphin is traveling after it enters or after it is above the water surface, because we don't necessarily care when the dolphin is inside the water, but as soon as it exits the water and it's leaping out, we want to know how much it's traveling by. And here we're asked, when will the dolphin reach a height of 1.82? So we want to find D such that h of D is equal to 1.8 feet. So at this point, we've seen quite a bit of word problems, so I encourage you to pause here and try to solve this on your own. And if you're still struggling, come back and I'll go over the complete solution, or just come back to check your final answer. But because we're focusing now more on word problems, I would highly recommend you try it on your own first to see where areas you need to work on are. Okay, so here we are trying h of d is equal to 1.8. Or in other words, maybe let me move this over, 0.2 d squared plus 2d is equal to 1.8. And let's move over the 1.8 so we have an equation that is equal to 0. Okay, and so here is where you might have had a challenge. And you might have used a graphing tool at this point, which is okay, but I'm going to show you a way that we could solve this just using algebra and no technology or no computer tools. So first we're going to convert our decimals into fraction form. So 0.2 is the same as 2 over 10 d squared. And 2, I'm going to just change it to that base of the denominator of 10 as well. So 20d minus 18 over 10. So now I'm going to factor out the fraction because they actually do have negative 2 over 10 as a common factor. You could have also tried here factoring out 0.2 as a decimal, and if you try dividing each of the coefficients by 0.2, you will get the same answer. So here we get d squared minus 10d plus 9 is equal to 0. And if you're unsure about this, just try your distributive property. See if you distribute this to each of the three terms, do you get the same three values that we had up there as well? So now, this is our basic quadratic with coefficient, where the coefficient a is equal to 1, and you can factor using decomposition. But we are going to keep that negative 210 over there. And here we get d minus 1 and d minus 9 equals 0. And if we use our zero product property, the d here will be 1 foot. And here, d is equal to 9 foot. And both of these values are positive. And for our problem, this actually makes sense because as the dolphin leaps up and follows that parabola path from its starting point, and that's our ocean, our ocean again, then we do have that, and let's say this is height 1.8 here. Then we do have that at 2 points, the dolphin's height is 1.8 feet. And those times are when it is at a distance of 1 foot, and at this point, 9 feet. And you would end your problem with your therefore statement. So therefore, the dolphin reaches a height of 1.8 feet at this horizontal distance 1 foot and 9 foot. And this here was our example of this definition we saw here, where although we didn't start with an equation that had a is equal to 1, we were able to factor out a to get a new expression or a new quadratic expression that we were able to factor, and we used decomposition. And the solutions to that new expression is the solution to our original equation as well, because that a of negative 2 over 10 doesn't make a difference when our product is 0. Even if you multiply that, you still will get 0. And that is a wrap on this lesson. So you do have some practice problems attached to the lesson on Google Classroom, so check those out, and I will see you all next lesson.